Hello everyone. In this video, we are going to discuss about the basics of machine learning. That is, we are going to just introduce what is meant by machine learning. Now, before we move on to what is machine learning, first we need to know what is artificial intelligence. Now, if asked, your answer will be artificial intelligence is a concept that mimics the human brain. This was a concept which was developed, say, during the early 1940s, wherein humans wanted the machine to act like them. So when humans wanted the machine to act like them, that is where they brought in the concept of artificial intelligence. So they wanted the machine also to think intelligently. The intelligence is a very unique characteristic of a human being, and humans wanted this intelligence to be imbibed in a machine as well. So if we want to define what is meant by artificial intelligence, then this is how we will define artificial intelligence. It is defined as the capability to which a machine can exhibit intelligent characteristics. So if we want the machine to think like a human, to act like a human, then the machine has to exhibit intelligent characteristics. So how is it done? How was it developed? All this is about artificial intelligence. Now let's move on to the different types of artificial intelligence. Now, when we take the different types, we have two broad classifications. One is the narrow AI and the other one is the general AI. But narrow AI is also called as weak AI, but the word narrow AI is the most oftenly used term. Now, what is meant by narrow AI? Narrow AI is nothing but this is the most prevalent kind of AI that we are using today. From applications that we use in the mobile phone to big data analytics, narrow AI is taking the world by storm. So, for example, if you look at the examples that I have listed down here, narrow AI is built for a highly focused set of tasks. Like, for example, chess playing algorithms for all your digital assistants, virtual assistants, and all the autonomous cars that are being designed today, the self-driving cars. All this works on the base of narrow AI. So technology which is built for a highly focused set of tasks. The name actually stems from the fact that this kind of artificial intelligence systems are explicitly created only for a specific task. So that is why the word narrow is used. So owing to this narrow approach and inability to perform tasks other than the ones that are specified to them, they're also called as weak AI. So I hope you understand why this type of AI is called as narrow or weak, because they are designed for a specific type of task and they will be able to perform only that task, and they have the inability to perform other tasks. That is why they are termed as weak. This makes narrow AI's intelligence highly focused on a particular task or on a particular set of tasks, allowing for further optimization and tweaking. So I hope what you understand is about narrow AI is clear. Now coming to the next type of AI, which is called as general AI. Now, when we talk about narrow AI refers to artificial intelligence that what we have achieved today, right? So narrow AI is something that we have achieved today. General AI refers to where it will be in future. So general AI is the concept of AI which will talk about where we are going to be in future in the area of artificial intelligence. So general AI is also called as strong AI. So what do we mean by this type of AI? See, general AI is a type of AI that can think and function just as humans do. So when we say general AI, they will be able to think and function like humans do, and that's why we say that general AI is built to improve the capabilities comparable to human. So it is something which could be compared with the human. That is general AI. And examples of general AI has been listed out here. The first example that I have mentioned is about a space odyssey in the movie HAL, which was released in 2001. This is nothing but this HAL is a sentient artificial general intelligence computer that controls the systems of the Discovery 1 spacecraft and interacts with the ship's astronaut crew. So if you see in the movie, if you watch the movie, this will be this is nothing but an AI. Okay, it is nothing but a computer which interacts with the astronaut crew and talking about the spacecraft and other things. So this is what this particular AI does in this particular movie. And then all would have seen the various series that we have in Star Trek, Star Wars film series. There is a robo called as R2D2. This R2D2 is nothing but it is an astromech droid in the movie Star Wars. It is a type of robo that usually served as a mechanic and backup computer for small spaceships. So this was like a mechanic and it was a backup computer for spaceships in the movie Star Wars. And another movie in a movie which was called as Her, HER. In that movie, the hero of the movie is a lonely and introverted man, and he works for a business and where professional writers were required to compose letters for people who are unable to write letters of a personal nature, right? So his job was to write letters for other people. So he becomes depressed, and then what he does is in this movie he purchases a computer, he purchases an operating system, and he upgrades that OS such that it will imbibe in itself a virtual assistance with artificial intelligence, and which is designed to adapt and evolve, and he gives it a feminine voice and calls that the particular AI, human-like AI as Samantha. So that the particular human AI Samantha will have the ability to learn and grow psychologically. This is what is depicted in the movie. Now, all this is all fictional. These are all fictional movies which foretell how general AI is going to be in future. So now I hope you are able to understand the difference between narrow AI and general AI. Now, coming to narrow AI tasks. Now, when we talked about narrow AI, this is what I told you. I told you that narrow AI is something that we have already achieved. That is when we try to build AI for a specific task or a specific set of tasks, then that is called as narrow AI. So examples for tasks that you can call as narrow are computer vision tasks, any language processing task, or any planning task. So all the computer vision tasks that we have, all the language processing tasks, that is the very good example is our Alexa, which processes our human voice and converts it into text and then replies to us. And then the planning tasks where we have our maps which are available, which helps us to reach our destination. These are all examples for typical narrow tasks. And coming to now, what is meant by machine learning? Now, if you look at the first diagram, this is our traditional programming, wherein we give the input and then we supply also the program and we get the desired output. This is our traditional programming. But when we talk about machine learning, it's completely different. That is, to our machine learning model, we supply the input data and we also supply our expected output, our test data, right? And what we actually expect is from the machine learning model is a technique for predicting what type of data it is. So that's how you say the output is a program. So this is what is meant by machine learning. So this is how this diagram clearly shows you how machine learning differs from traditional programming. Now let's move on to the proper definition of what is machine learning. So we need to now learn to define machine learning. Machine learning according to the person Michel in 1997 goes like this. Machine learning is nothing but a program to learn from experience with respect to some class of tasks, and the performance measure its performance at tasks as measured by the performance measure in order to improve the experience. So this is what is meant by machine learning. That is, machine learning is nothing but the ability to learn from past experience such and apply it on a specific set of tasks and measure the performance of the model that is built. And if there are any errors or any issues, then those issues could be sorted out or by improvising the performance. This is what is meant by machine learning. So now let's see what is meant by this. What do I mean by this class of tasks? What do I mean by performance measure? What do I mean by experience? That's what we're going to learn now. Now, when we talk about tasks, right? So here I'm going to feed into the machine learning. My machine learning algorithm is going to take up some set of data which is going to act as a training data. So the example of the task T are as some examples are as follows. Any kind of a classification with data or with missing inputs. And it could be any kind of, say, for example, I'm giving an email as input. Whether the email is a spam email or whether it is a non-spam email is called as classification problem. And if it's going to be predicting the weather, predicting the temperature, predicting the stock market, all comes under regression problem. These are all examples for tasks. Example for another task is transcription. What is meant by transcription? Learning speech to text, all the language processing. Okay, that is learning, converting the speech to text or image to text conversion. All that is transcription. Then coming to machine translation, that is translating English to other languages, right? And another example for task is structured output. For example, learning to mark the roads. That's our planning task. Okay. Then detecting anomalies. That is, for example, fraud detection, monitoring the health of a patient, denoising, density estimation. All these are examples of tasks. Now, what is meant by the next thing is what is meant by this performance measure P. How do we measure the performance of the model which is trained which is developed after training our algorithm with the set of tasks T? Now, coming to what is meant by this performance measure P, if you take for example, tasks like transcription and classification, the accuracy is what we measure. We need our model to give accurate results. So the performance measure is going to be in terms of accuracy. So what is meant by this accuracy? Accuracy is nothing but the proportion of examples for which the model produces the correct output. Sometimes I may get errors also. So based on the errors, I will be able to improve the performance of my model. So what is meant by error rate? Error rate is nothing but the proportion of examples for which the model produces incorrect output. So when I'm going to get the correct output, I put it into the measure accuracy. When it is going to be incorrect output, I put it into the measure error rate. Now, coming to what is meant by data. Now, what is the data that I'm talking about in terms with respect to machine learning? I have two types of data, that is my training data and my test data. Training data will be the data with which I'm going to train the model, right, which I'm going to give as input to the machine learning algorithm. Test data will be the data with which I test the model that has been built logically. And then I supply the test data and I make sure it is it runs properly. Now, coming to model is trained using the training set and performance is assessed using the test set. Deciding the performance measure is not always straightforward. For example, when performing a regression task, should we penalize the system more if it frequently makes medium-sized mistakes or if it rarely makes very large mistakes? Now, what is meant by the experience? Experience is nothing but learning from past data. That is what is meant by experience. Now, these are the different types of machine learning with which will be covered in our next video. So what we try to say is, with the right data and the right model, machine learning can solve many problems. But the question here is, finding the right data and training the right model only is the main question. So as of now, we will stop here, and then we will proceed with our next